Lesson 4.3, our outcome. We're going to write and evaluate a function. We're going to write and use function notation. And we're going to determine the domain and the range of a function. These two words, domain and range, should be very familiar. What does domain represent? The x or the y? Good, it represents the x. The range, what does that represent? Good, the y. Here we go. All right, so a function relates two quantities. That's its definition. A function is always something that looks like y equals 2x plus 3. Or sometimes we might use m equals 2s plus 3. You can interchange these variables, okay? But our common ones are x and y. Relating the two quantities. Well, that's relating our x and our y. Okay? These are the two quantities that we're relating. We're relating x and we're relating y. X is our independent variable, so it's going to influence the outcome or our output of y. I just dropped a lot of vocabulary. You might want to replay and write some of those vocabulary words down on. So here's what I want to show you. Okay? Oops, let me put these circles back so they match. Let's use blue for y and x for red, and you'll see why in just a minute. So here are my input values. My input, also known as x, also known as our domain. That's why I wanted to make the red go with the red, because x represents our domain. So if I put 1 into this function, my output, or the way that it's going to relate, is 1 times 2 is 2, 2 plus 3 is 5. That was my output. And y is always my range. Okay? That's why I wanted to have the blues matching. Okay? And you can go through this. This is simple math. 2 in for x. 2 times 2 is 4, plus 3 is 7. This is a function. This function is also a relation. That means that these numbers are related to each other by this function. That's what makes them a relation. And as we learned in a previous video, every function is a relation, but not every relationship will result into a function. This is a relationship, and this one, yes, does make a function. So that's the rundown of a function, okay? Our basic function. Well, now we need to learn function notation, because as algebra students, it can't be as easy as y equals 2x plus 3. We got to throw some other stuff in there. So we're going to do function notation. Let's get this out of the way. Function notation. Here's what it looks like. Take a look at that. F parentheses x equals 2x plus 3. So this part did not change at all, okay? X is still there. We just gave y a different name, all right? And we're saying f, which stands for function, parentheses. What operation is parentheses? Multiplication. And a word for multiplication is of. Let me get a pen here. Okay? So these parentheses mean of. All we're saying is y is simply a function of x. So whatever we put into x, that's going to determine what y is. Y is completely dependent on x. So y is essentially a function of x. It's just a matter of the way you write it. So if I wanted to put 1 in for x, 2 times 1 plus 3. The way it would look on this side is, I need a function when x is 1. So there's how I would write it. So when I want to know f of 1, so that means when x is 1. Plug it in, 2 times 1 is 2, plus 3 is 5. So f of 1 is equal to 5. When x is 1, y is 5. Okay? Here we go. Other appropriate names, it might not always see it as f of x. You might see it as g of x, h of x, or f of x. These are the only three that you'll hardly ever see. The most common will always be this one right here, f of x, okay? All right, let's do an example. You and your friends go ice skating. Because you don't own your skates, you need to rent them for $7.50. Each hour of skating costs $2.50. Write a function f that represents your total cost, so that would be our old y, our total cost, in dollars for if you skate for X hours. Let me get another pen here. Okay, so we know $2.50, that's important. Oh, each hour, that's probably important. $7.50, important. We're going to write a function. So here's one of our f of x deals. Okay? So you try to write the function and see if you can write it correctly. You might want to pause me because I'm going to give the answer. Here we go. F of x, my function of x. Essentially my old y. In the olden days, that would be y, but now you're algebra students, so we can write the function of x equals 250x plus 750. X standing for the number of hours, which is said right here, and f of x being my total cost. Now we have to talk about our domain and range. Well, x is my domain, okay? What values can I put in for x that would make this true? Well, x stands for my hours. Ask yourself, can you have negative hours? Would that make sense? No. So we're going to do a little set notation here. Can I have 0 hours? Yes, I can. That would be okay. We can have 0 hours. Can we have 1 hour? Can we have 2 hours? Can we have 3 hours? See where I'm going with this? Our hours are all whole numbers. So this is my set notation. My domain can be any of these values. It cannot be negatives. So my domain, if we go back to our real number system, which one had the 0 and all the positive numbers? Good, it was whole numbers, okay? All whole numbers, all right? So that would be my domain set. Now we want to look at our range. So if I'm only putting in positive values for my range, or I'm sorry, for my domain, then my range, my outputs, should they be positive or negative? They should be positive, okay? And my range is my total cost. So let's do a set notation for range. Let's see, can I extend the page here? There we go. And let's do this. Oh, that didn't work. Let's do extend the page. There we go. Set notation. If I go in for 0 hours, how much am I paying? It's going to be $7.50. I still have to pay that $7.50. Okay? So, are my numbers, are the rest of these numbers going to be bigger or smaller than $7.50? Because at 0 hours, I still had to pay $7.50. If I go another hour, well, what's $7.50 plus $2.50? $8.10. Okay? And then I can start going on. You don't have to go on for infinity because that could go forever. Just put 3 dots and close your bracket. And that's my set notation for my range. I'm saying that if I put in any of these numbers above 0, I will get out these numbers below, which are all positive and they're all increasing. That's my set notation. All right, final slide. We've already discovered that this is a function of x. So instead of y, we're now writing f of x equals 3 minus 5x. Okay. This is saying domain is any real number. Any real number. Can that be positive? Can that be negative? Can it be a decimal? All of those are true. Okay? So any real number. So I could plug in -1, If I put negative 1 in here, negative 1 times negative 5, well, that's going to give me a positive 5, plus 3, that gives me 8. Okay, that's a positive number. Now, I've done a couple here for you. I did 0, that's a real number, and you can figure out what I would get out. I've plugged in negative 3 as one of my domain values. You can do the calculations and figure out what you would get. And I've done positive 10 as a domain. Is positive 10 part of any real number system? Yes, it is. You can plug that in and see what you get. If I put any real number in, what am I going to get out? Can I get positive numbers? Negative numbers? Could I potentially get a decimal? Yes, it's all real numbers. So if I'm putting in all real numbers, what's coming out are also all real numbers. And this is set notation. Let me write that for you. Okay, that would be another keyword to write down, set notation. It's using these brackets to define what makes this function true. Review your outcome and make sure you've answered all these questions. Can we write and evaluate a function? Did we write and use function notation? And did we determine domain and range of a function?